The next key is the diameter key. The diameter is a nice key because it gives you the ability to measure your diameter and calculate roundness at the same time. So we're going to come over to this diameter. I'm going to line my cross here on the first point of the diameter. When you calculate diameter, you want to take a minimum of 3 points, a maximum of 99. You press the circle key. It's looking for points. You're right on probe circle. It wants you to enter the points. So I'll enter my first position. I'll enter my second position. My third. Now if we take any more points beyond 3, it'll actually calculate the roundness of the diameter for you. So I'm going to take a few more. 4. So it'll tell you the best fit diameter relative to these points and the outliers that fall in and out of the best fit diameter. So I've calculated 6 points now around the diameter. If I didn't like one, I could always cancel it out. And it counts you back down to the 5 positions. So I'll enter that anyways because I did like that point. Now I have 6 points to evaluate. I press the finish key to tell it I'm finished. And outs points me to circle 6. You notice the feature list numbers the points relative to the order they're taking. It'll store up to 99 positions in the memory. So how do I evaluate the circle? Well, it's telling me that the XY position of the center of that diameter is 2494501 from where my 00 was, which I believe was the center of 4, which is right, angle 4. So it's telling me the distance from angle 4, the corner. If I want to know the straight line distance to that corner, I can hit the polar key and it tells me the straight line distance is 2.3046 from the center of that diameter to that corner I made 00. More importantly, you have your diameter down here, 3691. And if I want to know the radius for whatever reason, I can toggle right to radius, 1845. If you look at the output, it'll say I took 6 points and my form is 1,009/10, almost a 2,000s form. So it's telling me how well that circle calculated relative to the points it saw. You saw I had a lot of chatter on the edge. It's probably why it's such a high form, 2,000. Now if we view it, it actually calculates the diameter for me and shows you that 1.9 band around the outside, telling you the overall form, where that circle lies. Now, the nice thing about this circle, let's say you had a circle that you needed a post to go into. So you want to know the minimum diameter, not the least squares best fit. To do that, you would hit the change key and ask for the inner diameter. And it would actually calculate the inner diameter, throwing away the outliers. So this will tell you the minimum diameter that something can fit into that hole. Similarly, if you had a post, and you want to know how big the post was maximum, because you're going to put a sleeve over it and it can't be any larger than the sleeve, you would hit the change key and then the outer button, and it'll calculate the outer diameter. So you'll notice the diameter is 3702 in the outer diameter, and the inner diameter is 3684. So basically it's adding and subtracting that roundness. Now, we showed you distance key. Let's do another diameter, and we can do the distance now between two diameters, now that we know how to use the distance key. So we're going to come over, we're going to calculate this other diameter here. Quickly, enter my points. So there's 2, 3, and the last one, 4. Calculate my diameter. Again, it's output 7. XY position from my 00 point, which is my corner. My diameter, 750 thousandths, 2/10. My radius, 375.1. The form out of the 4 points is 4/10, and there's my view. Now, I have circle 1 and circle 2 in the memory, 6 and 7 in the memory. If I want to know the distance between these two circles, the easiest method would be just to ask for a distance key now. I know where 6 is, I know where 7 is. I'm going to say give me a distance. Recall 6. Recall 7. Tell it you're finished. It'll calculate the distance between, you'll say from 2 features. We're giving you a distance. You'll review it. My distance is 1 inch, 1/10. If you view it, it actually shows you the distance between the two diameters. Now you might want the nearest distance, the inside diameter there. You can view it. Go to ask for the nearest distance, and it actually calculates that inside distance for you. Similarly, if you wanted the overall distance between the two diameters, ask for the farthest, and it actually gives you the furthest distance on the outside. We move our readout, it gets back to current position, and we can see where we are. The nice thing about it is you have your output on your feature list, and you can at any time go back and look at any feature that you may have created. And again, all this data can be toleranced and dumped to a printer with pass-fail results. Now, let's say we had, the next game I'll show you is the line key. The line key is a quick way of checking straightness of your line and also how parallel or the angle of that line is relative to your 180 axis. The machine considers the axis 180 unless it's skewed. In this case, it considers the top of the part. It's 180. So we're going to come over here and we're going to enter the first position on the line. We're going to ask for the line key. We did. Enter our first position. We're going to take again a minimum of 2 points, a maximum of 99. Let's take a bunch of points along this edge. So I took 5 positions. I tell it I'm finished. And it tells me the angle of that line relative to my 0 axis, which right now it's within 4 minutes of being 180. If we view it, then it'll actually show you the points I took, and it calculates a form or straightness of 7/10. It's also on this screen, 5 points, 7/10, and it tells you how straight my line is. Now that I have the line in the memory, I can use that as angles or intersection points or anything of that nature. So, for example, if we want to know where this line intersected the arc on my machine here, I have a line. What I'm going to do is I'm going to calculate the arc. So I'll come over to my circle key. Diameters and arcs are the same. Enter my first point. Second point. Third point, and in this case, the fourth point, finish. Okay, so now I've circled 10 in the memory. If I view it, it actually shows me the arc I took. I want to know what the radius is, not the diameter, so I'll toggle. And now I know my radius is 187.5. Now, let's for example say we want to know where my line number 10 intersected my line, or circle, my line 9 intersects my circle 10. So here's line 9 right here, and here's arc 10 right here. So now I'll go back to the readout, and what I'll simply do is I'm going to press the point key, because if a line and a circle intersect, what do they create? They create a point. So I'm going to recall again, line number 9, and then recall circle 10, or radius 10 in this case. Press enter. It says construct points. My 2 points are checked off. I hit finish. And it tells me the XY position of that point in space. And if I view it, it shows me the exact tangent point of the line in the circle. This is a nice trick to find. A lot of times in your print you need to find the tangent of a radius and a line where that point breaks. This mathematically will do it for you.